Now, we are going to look at the displacement and distance. Let's consider the same point A and point B. You will have point A here and point B is here. Okay, this is your reference point. Okay, let's say the distance from point A to your reference point is 3.61 and the distance from your reference point to B is 6.4. But now you are going to point B from point A. Let's say you are walking in following the road. Kadang-kadang jalan kita kan bukannya straight line kan. Jalan kita something like this. Let's say your distance is something like this. The distance that you take from A to B using red path, kita panggil dia sebagai, contoh dia you lalu dia 15 km dalam masa yang you ambil sebanyak 30 minit ataupun half an hours. Okay, laluan, okay, jalan yang awak lalu kita panggil sebagai path. Ini adalah laluan. Okay, laluan. Alright, by definition, distance adalah actual path taken. Actual path taken. So your distance here should be 15 km. Alright. Okay. Displacement ada dua explanation. Okay, yang pertama, displacement should be, by definition, displacement is equal to change in position vector. Okay, change in position vector. Now, the symbol usually used for displacement is S. Kita nak change in position vector. When you find the word change, okay, anything coming after that should be final minus initial. So, position vector, we know the symbol is R. So, you will have here the change in position vector is R final tolak R initial. Change in position vector, change in, we will be symbol it as this triangle, calling it as delta. So, position vector is R. We put it R here, delta R. Okay, now we have learned before this, A have RA as its position vector and B has RB as its position vector. Okay, jadi kita nak tolak final tolak initial. So our final position vector should be RB lah, sebab B kita punya final position. Tolak initial vector RE. Final tolak initial. Alright, so RB minus RA. Kalau kita buat what we call tips to tail method. Tips to tail method. Okay, kita ambil RB. Okay, so let's see sini. Saya ambil kotak yang sama. 1, 2, 3, 4, 5 sampai sini. Okay, so this is saya punya RB. This is RB. Okay, RB tolak dengan RA. Maksudnya RB kena tambah dengan negative RA. So, negative RA should be something like this. Bukan. Oh, salah. RB saya kena lagi atas. RB saya sampai sini. So, this is RB. Okay. So, RA saya is something like this. Okay. You can see that if I move it here, it the same length. Oh, lain. Saya buat balik. Okay, it should be salah ni. Dia 3 je. Alright, something like this. So if you look, my RA should be ni negative RA. So my RA here is the same length and length and direction, but different in opposite direction. My RB should be same as here. So I put it here. So I will get RA minus RP here. Then what I need to do is sambungkan ekor RP kepada kepala RA. So saya dapat delta R saya di sini, which is this delta is the same as the distance between A dengan B. Kalau tengok situ, distance between A dengan B. Okay, this is the delta R. Okay, this is the definition for displacement. Okay, cara paling senang kita boleh dapatkan magnitude for distance. Boleh dapat magnitude for distance by using the shortest distance from initial to final position. Kalau kat sini from A to B lah. Okay, from A to B. Jadi how did I got A to the final position is saya cari delta RY dan saya cari delta RX. So delta RY ni dapat daripada RBY tolak dengan RAY. Delta RX saya dapat daripada RBX tolak RAX. Kita tengok daripada this coordinate, untuk A, X component dia negative 2, RAX dia negative 2, RAY dia negative 3. Untuk B, RBX dia negative 5 dan RBY dia 4. So saya guna je lah kat sini. 4 minus 3, saya dapat delta RX saya 1. Yang ini 5 minus 2. So I got 7 here. Okay, using the Pythagoras theorem, I will get it as delta R saya bersamaan dengan 7.07 km. Then the theta here using, saya guna warna lain lah. Okay, theta kat sini saya dapat theta direction kita akan dapat kalau displacement from dia akan pointing from initial to final position. So for delta R, kalau kita daripada A ke B, dia akan pointing from A to B lah. Daripada A ke B. So this is our position vector. Another ways to find it by using tangent minus 1. 1 divided by 7, you will get it as 8 degree above positive x-axis. Alright. Okay, this is your the difference between distance and displacement. So the distance taken is 15 km and the displacement taken is 7.07. Okay, SI unit for both displacement and distance is in meter. Okay, let's say you are moving from point A, let's say point X1 to point X2, which is point X1 in 0, 0. X2 is, let's say, 50 km, which is you are moving in straight line. Okay, when you are moving in straight line, right, your distance and displacement is the same. Okay, for example, this one, the distance is 5 km, the path taken is straight line, the displacement is also the 5 km. The difference is the displacement has direction. The direction is to the right. Okay. Another example is when you have a ball, you throw it upward and it goes like 1.5 meter. Jauh sangat tu, 3 kilometer. 1.5 meter and it drop back to your hand. Drop back to your hand. Okay. This situation, you will have the distance, which is the actual path taken by the ball. The ball is going upward and down again. You will have 2 times the height. The distance is twice the height lah. Sama dengan 2 darab 1.5 kilometer. 1.5 meter. So you will get 3 meter for the distance. But for the displacement, it look like the ball is not moving at all. So your displacement is 0. No direction lah sebab dia punya displacement 0. Okay? Okay, that's all.